Alright, Algebra 2. Today we have the fun of moving into matrices. And yes, I think they're pretty fun. Some people are scared by them, but it's just because they don't know what they are. So I'm going to teach you what they are and teach you how to do some operations with them today in 3.5. So real quick, guys, I put this slide in here not to advertise the movie because I believe it is a rated R movie and very violent, but I do know that it's popular among teenagers. At least it was back in my day. But The Matrix, the movie, is actually very, very related to this idea of matrices. And I get more into that in pre-calculus and on how it's related. But they chose the name of that movie because it is very related to a matrix that you learn about in math. So what is a matrix? A matrix is simply a rectangular array of variables or constants in horizontal rows and vertical columns. They're described by their dimensions. This is very important here, that they are always described with a row coming first, column coming second. Okay, so what does that mean? That means if I said that one of the matrices that we're talking about is a 2 by 3, what that means is it would have 2 rows, 3 columns. All right, so maybe it's like 3 here and a -1 here, and I'm just totally making this up. 4, 5, -7, and 1. Okay, so maybe that's the matrix. It's just a rectangular array of numbers. And this one would be a 2 by 3 because there's 2 rows, 3 columns. And that is very important. All right, so if I said, give me a 3 by 2 matrix, it would look a little different. Okay, a 3 by 2 matrix would look like this. And I'm just going to put in random numbers here again. So this is going to be 3 rows now, right? 3 rows, because this first number represents rows, and 2 columns. All right, so rectangular array of numbers, it's labeled with row first, then column. All right, so guys, for adding and subtracting these things, it can only happen, this is very important here, this can only happen if the matrices have the exact same dimensions. So if we're going to add 2 matrices together, we can only do it if we have the exact same kind of matrix with the same dimensions. What that means is if I have a 2 by 3, let me switch back. If I have a 2 by 3 matrix, there's some examples down here as well. But if I have like a 2 by 3 matrix like I did up here, so if I have that one, 3, -1, 4, 5, -7, 1, if I want to add that to another matrix, it has to be another 2 by 3 matrix. So if I was going to add or subtract this to another one, we can make one up here, -2, 6, 3, 7, 1, 2. Okay, I can add those two together as long as they're both 2 by 3s. When we get into multiplication, that changes a little bit, but for adding and subtracting matrices, they have to have the same dimensions. Okay, so you can kind of remember that, like when you're adding and subtracting fractions, you have to have a common denominator. When you're adding and subtracting matrices, you have to have a common dimension. All right, so they have to be the exact same. And then we just perform the operation after that. So it's actually pretty straightforward. So here, if we're adding these together, we would have 3 plus -2. So by the way, the result will be a matrix that's the exact same, right? So same dimension. So 3 plus -2 would give you 1. And then we could do 4 plus 3, which would give me 7, right? And then I can do -7 plus 1, which would give me -6. And then I can do -1 plus 6, which would give me 5. 5 plus 7, which gives me 12. 1 plus 2, which gives me 3. Okay, so hopefully that makes good sense to you, you're just matching the two. And that's what they did in these examples as well. So here, when you're adding A and B together, be careful with this one, though. This one, A and E, A plus E makes sense. I don't know why they did that. This is a mistake. So be very careful jotting that down, because the second one should actually be, so good thing I looked at this here, it should be B plus F here. B plus F. All right, then C, that could confuse you. So if you're looking at that, we have C plus G here, and then here we have, it should be DH. So they really messed this one up. D plus H. Okay, so sorry for the confusion on that one. I think the rest of them, I think they got correct. Yeah, we have A minus E, B minus F, C minus G, D minus H. All right, so just be careful of that one. If you're looking in your textbook, that's probably where that came from, so just be careful. And then they give you an example like I did. So here we go, guys. Let's get right into it with 1A. So with 1A, we are going to just subtract these two matrices. Before we do anything with example 1, we want to make sure they're the same dimensions. And here they happen to be. So they're both 2 by 2. So I can therefore subtract the 2, because that's what they want us to do. All right, so we're going to subtract them. So when I go to subtract these, I get -3 minus -4. Be careful with your symbols here. -3 minus -4 gives you -3 plus 4, which is just 1. Okay, then -3 minus 12 will give me a -8. -9 minus 8 will give me a -17. And then -5 minus a -7 is -5 plus 7, which gives me 2. So there's my answer to 1A. 1B, and in your books, this could be example 1, or it could be example 2, because I think with the updated textbooks, I think this turned to example 2, so don't let that confuse you either. Not sure what it is in your notes, but here we go for another one. If I'm adding these now, -9 plus -4 gives me -9 minus 4, which is -13. Okay, 8 plus -3 is just going to give me 5. 3 plus 6 is going to give me 9. Then we're going to go down below here. -2 plus -9 gives me -11. 4 plus -5 gives me -1. And -7 plus 18 gives me 11. Okay, so it's as easy as that. Then moving into the next example, you guys, we're going to multiply by a scalar. Okay, so to multiply by a scalar, I want to highlight this, and I made sure that I put those two little asterisk signs there by these, because look, guys, with this one, when we multiply by a scalar, the process is way different than if we're multiplying two matrices together. So don't get this confused. We are not going to multiply two matrices together today. We are only going to multiply by scalars. Okay, so what that means is we're going to take a number out front, and we're going to multiply by everything inside. That's all it is when you multiply by a scalar. That's all they're doing here. So you have -3 times 4, -3 times 1. It's kind of like distributing, right? We're just distributing the scalar to each of the numbers that are in the matrix. Okay, so for 2, it says find -4t if t is equal to this matrix. So what they want us to do is they want us to take -4 and multiply it out by the whole thing. Okay, so I'm gonna set it up like that. And then I'm just going to perform the multiplication piece on it. So when I do that, I get -32, 0, -12, 8, 4, 16, 8, and -36. In pre-calculus, we use scalars a lot because we end up trying to use matrices to solve systems of equations, which is why it's in the section on systems of equations here in Algebra 2 as well. But we often multiply by a scalar to turn things to ones or zeros. That's essentially what we end up doing in pre-calc. But for now, we're just going to practice using a scalar. Okay, so that's example 2. So multi-step operations, Here we're just going to follow our order of operations, so we're always going to be multiplying by a scalar first, and then we will add or subtract as needed. So number 3 here, example 3, is just going to pull it all together, right? So we're going to take negative 6 times matrix B. Okay, so I'm going to set this up. Here's matrix B. Be careful with your A's and B's. Okay, so I have matrix B here times negative 6, and they want us to add that to 7 times matrix A. Okay, so I'm just copying that down here so I can perform the operations. All right, so I'm just going to rewrite this below. I'll do this in red. Okay, so I'm gonna multiply it out. So when I multiply this out, 7 times negative 5 is negative 35. 7 times 3 is 21. 7 times 6 is 42. 7 times negative 8 is negative 56. 7 times 2 is 14. 7 times 9 is 63. And then I'm going to add that to, okay, negative 6 times 12 is going to be negative 72. Negative 6 times 5 is negative 30. And then I have negative 30 again. And then I have positive 24, negative 24, and then positive 42, because a negative times a negative is a positive, right? And they want us to add these together. So we're going to add them together. Okay, so for our final answer, here we go. We're going to get negative 107. And then 21 plus negative 30 is negative 9. 42 plus negative 30 is going to be 12. Negative 56 plus 24 is going to be negative 32. 14 plus negative 24 is going to be negative 10. And then 63 and 42 is going to be 105. And that would be our final answer. So that's example 3. And then example 4, or it could be 5 in your notes, I don't know which it would be, says the data represents 5 days worth of company data, uses to calculate average yearly sales and wages for the company, assuming 260 work days. Think about your scalar, it is not 260. Okay, so for this one, if we have 5 days worth of company data here, and there's 260 working days, they want us to multiply this by a scalar to figure out the whole year. Okay, so what we have to do then is we have to figure it out. It's not 260 because this is 5 days worth of data. So we actually have to take 260 and divide it by 5. And when we do that, we get 52. And that makes sense because there's 52 weeks in a year. So that makes good sense. Now let's multiply that 52 out by what we see inside. All right, so when we do that, I'm not going to take the time to run all these calculations on my calculator, but when we do that, what you should be getting when you do this is, let's just make sure, yes, when you do this, you should be getting 741,000, 1,560,000, 1,638,000, and then here for under sales we have 97,890,000. Didn't quite make my matrix big enough. 131,430,000, and then 156,130,000. All right, so we're just basically taking a matrix and showing you how you can apply it to modify, a number of different types of data at once. So we looked at wages, we looked at sales, and then we looked at the various levels of employees and how that data adds up over time. All right, so this is matrix